Here's a slightly trickier case. We still need to identify the parent system. We have a 5-membered carbon ring and we have a 6-membered carbon ring. So the longest carbon sequence is 6. This 6-membered ring is our parent system, our parent, in this case, ring. So we've got hex for 6, cyclo for the ring, which gives us a name for the ring system of cyclohexane. Okay, that's the parent ring sorted out. Now we need to give the location of the functional groups that are attached to the parent ring. And here comes the problem. In this example, every single one of the 6-membered ring carbons has a functional group attached. So if we were to do the calculation, we would find they all come out the same numerically. What we need to do now, only in this situation where we're at a stalemate if we do numerical calculation, is look to alphabetical calculation. So of our functional groups, we look at the names and say which has the lowest alphabetical letter. The answer to that question here is tert-butyl. Remember, we don't count the T in tert-butyl. We start at the B for butyl. So B is the lowest first letter here. This will be carbon 1. Now we've got to choose. We can either number clockwise or we can number anticlockwise. Where you have an even number of carbons in your ring, the carbon opposite to carbon 1 is always going to be the same. In this case, it's carbon 4. So we don't really worry too much about that carbon. Excluding, in this case, carbon 4, we're now looking for the second lowest lettered functional group. As we look round, what we find here is that we're looking at cyclopentane. It's the C of cyclopentane. So the lowest letter is B for tert-butyl, second lowest letter is C for cyclopentane. Now, if we number anticlockwise, that carbon of cyclopentane will be 3. If we number clockwise, it will be 5. We want it to be the lower of the two numbers, so that's 3, and we are going to number anti-clockwise. Right, so that's the numbering sorted out. We now move to naming the functional groups and placing them in alphabetical order. What we're looking at is tert-butyl at 1, methyl at 2, cyclopentyl at 3, methyl at 4, ethyl at 5, and finally isopropyl at 6. So the final name is 1 tert-butyl, 3 cyclopentyl, 5 ethyl, 6 isopropyl, 2, 4 dimethyl cyclohexane. Remember, the di indicates there are 2 methyl groups here.